Welcome to my channel CSIR-NET Chemistry Facts. Today we will discuss about the CSIR-NET December 2019 Part C question. It is a 4 marks question, and here you can see this is the question on your screen. Here this is the starting material stated with this 4 reagent and what will be the product we have to determine. And there are 4 options are given. Among these 4 options, which one will be the correct answer we have to predict. So guys, let's start the mechanism. So you can see the first step is HBr addition. So what is HBr? HBr is a acid, right? So HBr can be dissociated like this, H plus Br minus, okay? And this H plus can be consumed by any of the keto present in this starting material. And if you see the starting material, there are 1, 2, 3. 3 ketos are present. So guys, which keto will take the proton? So if you see this nitrogen lone pair will assist to take the keto, take the proton by this keto, right? So this lone pair is assisting this keto to take the proton, and this lone pair is assisting to this keto also to take the proton. So therefore, the same lone pair, the single lone pair of nitrogen is assisting 2 carbonyl carbon to take the proton. So therefore, each of the carbonyl carbon is getting 50% assistance by the nitrogen lone pair. So this carbonyl carbon will getting 50% assistance by nitrogen lone pair to take the proton, and this carbonyl carbon is getting 50% of the assistance of this nitrogen lone pair to take the proton. And if you see this side, this carbonyl carbon that is adjacent to this oxygen, and oxygen has 2 lone pair, and oxygen can give this lone pair to take the proton by this carbonyl carbon, and there are no other carbonyl carbons present with this oxygen except this one, right? So therefore, this will get 100% assistance by this oxygen lone pair, okay? So there are 100% assistance, and hence this will take the proton rather than these 2 carbonyl. So therefore, this will consume the H plus, okay? So what after consuming the H plus, what will form? It will form this one. This will be the OH, and here double bond O, and here a positive charge. Okay, so this will form. So this is the intermediate, and you can see the Br minus is generating. This Br minus will come now, and it will take part in the reaction. So this Br minus, why it will attack? This is a nucleophile, right? So it will search for an electrophilic position. So you can see this is the electrophilic position, and this is the electrophilic position, and this is the electrophilic position. So this electrophilic position is actually because of the carbonyl carbon, but this electrophilic position is because of the charge. This carbon has the attachment with the oxygen having a positive charge, and hence the electrophilicity of this carbon is much more higher than the carbonyl carbon, okay? So therefore, this is the most electrophilic position, and hence the Br minus will attack to this position specifically, and this bond will open up and it will give the electron to the oxygen to neutralize. So guys, what will form? So this will form, okay? So now in this, so this is the product of the first step. Now in this the second reagent is given. So this is the methanol and H plus, and we know the alcohol and the H plus when treated with this oic acid, then it will form the ester, right? So this is a esterification reaction. So this methanol plus H plus, so this will go for the esterification. That means OMe will come here. Actually, what will happen? This oxygen lone pair will take the proton, so it will form the OH2 plus, okay? After that, this methanol oxygen has the lone pair, and that will attack here, and this will open up, and this will close, and this H2 will remove. So OMe will come here. So I am not going for the details mechanism of this esterification reaction because it is already very well known reaction. So I am writing the product. So guys, this will be the product, right? So now this product is treated with this reagent. This is the AbPOAT whole 2. So what is this reagent? This reagent looks like this phosphorus attached with a methyl, OET and OET. And this phosphorus has a lone pair, okay? So this lone pair will search for a electrophilic position. So which one is the most electrophilic position? Here we have to consider the leaving group ability. You can see if it is attacking here, then this CN bond will break, right? Because if it is attacking here, then CO bond will open up and again it will close, and then this will come like this. So the CN bond will break. And if it is attacked here, then the CO bond will break. And if it is attacked here, then CBr bond will break. So we know the CBr bond breaking will take the lesser energy compared to the CCN bond breaking and CO bond breaking. So therefore, this lone pair will specifically attack to this position to break the CBr bond, which will take the least amount of energy. Okay? So this will attack here and this will come out. And as the phosphorus is given its lone pair, so therefore a positive charge will come on its head. Okay? And this positive charge can be neutralized by this oxygen lone pair. So this oxygen lone pair will donate to the phosphorus vacant d orbital and it will form a double bond between the phosphorus and the oxygen. Okay? And if double bond formation will happen, then what will happen is that there will be positive charge generated on the head of this oxygen, right? Because oxygen will give the electron. And this ET will be like this, okay? And this counter Br minus what is coming out, this Br minus can attack here and this will open up, okay? And this CH3 CH2 Br will come out and this P double bond O will form. So guys, this will form. So this will be the product, okay? Now in the fourth step, what is given? H3O plus means hydrolysis will take place. So guys, hydrolysis what will happen here? You can see this ester group is there, and this ester group after hydrolysis it will form the acid, right? Because it will take the proton, it will come out, and H2 will attack here, and it will form the OH, right? Instead of the OMe, OH will form, and you can see this H3O plus in the water is actually it will divide it like this, H3O plus OH minus. So it will produce a little amount of OH minus, right? This OH minus can attack to this position and this can open up and then again it will close and this bond will break and take the proton. Okay? So the NH will form here and the same story will be here. And this can attack here and this can open up and this can come close and this can take a proton. So guys, NH2 will form in the place of this nitrogen, right? So NH2 will form because both sides it will take the proton. So you can see this is the side product. So it is coming out like this and this one will be OH. And here NH2 and then so this amino acid will form, okay? So this is the product, okay? So this is the final product. So guys, you can see now in the options, if you see option number 1, 3 and 4, so here also olefin formation will take place, here also olefin formation will take place, here also olefin formation will take place. But in this reaction mechanism, no olefin formation will happen. And therefore, this option number 1, 3 and 4 are the wrong answer. If you see option number 2, it is exactly showing the structure what is produced here. So therefore, the option number 2 is the correct answer. So guys, Hope you understand this mechanism. Thank you so much for watching this video. Please like, comment and subscribe this channel, and I will come for the next video tomorrow. Okay, thank you very much.